Let's say we have an ice cube. The ice cube melts at a rate of 2 centimeters cubed per minute. What is the rate that the surface area is changing when the volume is at 1/8 of a centimeter cubed? So, as you can see, I've started marking values to use at the top right. These will definitely be used later. So, immediately, let's see what's going on. As this cube melts, its volume decreases. Duh. But as this cube melts, its surface area also decreases. Also duh. So, to switch from rate to rate, we have to find what both things, given and desired, have in common. We have to find the relationship between them. So, let's label what the equation for volume is. Volume, V, is equal to the side length of the cube, S, cubed. And surface area, A, is equal to 6 times S squared. Easy enough. Now, side length is not included in the prompt. We care only about volume and surface area. So let's eliminate side length by solving for it and setting the equations equal to one another. Now we have a relationship between the things we care about, volume and area. But we need to differentiate this equation if we want to get rates, because the derivative of a value is its rate of change. And this equation looks like chain rule and power rule hell, so let's simplify it to something a bit more manageable by hitting each side with a power of 6. That looks better. Now we can differentiate. First of all, both of these changes are happening over time, which means our differentiation is going to be some difference in the function over some difference in time. So that means every time we see a variable v or a, it will be differentiated by itself over time, which is the rate of change. So we use what we learned from implicit differentiation. Take the derivative of each side. The derivative of v squared is 2v times dv over dt, because v is a function, meaning we must apply the chain rule. Putting the dv on the outside is what applying the chain rule gives us, but because we differentiate for the function over time, because we want the rate of change, we also add that dt on the bottom. A is the same process with different letters. Simplify this down to look a little nicer, and now we have the relationship between the rates of change of the functions, which is exactly what we want. Now, notice how many variables we have in this equation. It's a lot. But the question doesn't ask us for the rate. It asks us for the rate at a specific time. So let's cut some down because we can. We labeled in the top right what we want to find and what the prompt gave us, so let's substitute those values in for our specific instance. Then simplify. But wait, we're still left with one more, area. So let's solve for the area at our given volume. We have the equation for volume versus area already, so let's just use that. Then algebra. Alright, now we've got the area. Now we have all the variables necessary to solve for the rate of change of the surface area. And now we have our answer. Surface area is decreasing at a rate of 16 centimeters squared per minute.